everyone, my name is Lara Figueiredo and I'm studying mechanical engineering at the Federal University of Rio de Janeiro. I'm the team leader of UFRJ Nautilus. I have been here for almost 3 years and a half, and I'm the mechanics and hydrodynamics coordinator of the team. And I have been participating actively and coordinating this project that we present this year. And in this video, we will be talking about the hull design of our new AUV, Lua. And let's go! Our last AUV, called BR Hull, showed some problems when we were testing our beamforming algorithms due to a lot of vibrations interfering our hydrophone acquisition. And we were commonly stuck at our 3D project. And by that I mean we couldn't just adapt our physical projects, test several scenarios in order to give a more accurate feedback from our softwares. In short, this new AUV was made in order to enhance some of our skills, correct some of our mistakes, and focus on diminishing some of our structural interference on our used algorithms. By choosing to use mostly polymer as a material, we have a lighter AUV. And by adding 2 new thrusters, making a total of 8 T200 Blue robotic thrusters, we have a vehicle with much more mobility. Talking now mainly about the hood design of our AUV, kindly called Lua, we have here a different geometry of an acrylic hull, 2 support arms that were used to accommodate our thrusters, an attachment to the frame used as an enclosure to our battery and power system, a frame used to support our actuators such as our hydrophone supports, our torpedo launcher, our ball dropper, and our mechanical arm. An internal part built to keep our PCBs and sensors in a tight and organized way. A so-called belt where we have our connectors and where we open our hull. And last but not least, an exoskeleton added in order to guarantee an easier and safer access to the electronic part. And with all that said, we close here our subsystem overview section of the video.
Now, it comes the important question. How does all of these previous presented topics and decisions made will contribute to our team competition strategy of this year? And the answer comes through by analyzing some of our 2021 goals. I'm just going to say the ones that better fit our video topic, which are 1. Complete tasks with the use of the hydrophones, focusing on finding the fingers. 2. Improve our slant method. Talking first about our strategy to facilitate the success of tasks related to the fingers and hydrophones. By placing the thrusters at the sides of the AUV, more specifically at our support arms, and by using a polymer, we can reduce the vibration caused by the thrusters, therefore interfering less the hydrophone data acquisition, hence improving our success rate when using our beamforming algorithms. And with that improvement, on our software, we can enable our AUV to successfully surface inside of the octagon and be ready to, in the future, be able to realize the torpedoes task. Another important consequence of decreasing the vibration is refining the response of our IMU. And that brings us to our next topic. Now for the improvement of our slant method. With this new geometry of an acrylic hull, we have more space to use 2 webcams as a stereo camera, and more freedom to use whatever distance between them that we choose fit. That's crucial to our project, given that during our physical tests, we can adjust the best arrangement possible, even if that differs from the one at the 3D project. With these 2 improvements, we can refine the data query, and as a consequence, improve our slant method and have a better performance at all tasks. This improvement affects directly every task because by guaranteeing a better sense of localization to our AUV, we can have a better control system of its trajectory, and with that, gaining more mobility and move with more precision. In short, a hood design with less influence of vibration, guaranteeing success on finding the fingers, and more space to the cameras for the cameras, that in combination with less vibration results at a better control system of the AUV, and with that helping all tasks. And that's it for our competition strategy section. Now for the development and testing section. I would like to start by saying that the COVID-19 pandemic was and still is a big problem for us in Brazil. And because of that, we couldn't build and develop as much as we'd like. But that was not and it's not going to stop us from working as hard as we can. Therefore, we had to focus on our simulations to ensure that we would minimize the number of setbacks we are going to find whenever it becomes possible to physically work at our AUV. Unfortunately, our simulations were not able to quantify specifically how the vibration affects the IMU and the hydrophones, that acquisition. It was only possible to see it from a bigger picture. Because of that, we will not be inserting any of them here. As for mechanical matter, we simulated mostly the deformation caused in each different material given a known force. For an example, we simulated the deformation on our support arms, given the weight of the main structure and the force caused by the thrusters. Two simulations were made. One to analyze the response of the UHMW polymer, and one to analyze the response of the aluminum. In this simulation, we see the polymer deformation that was smaller than the aluminum deformation. Other than that, 3 other parts were simulated. Another simulation made was to find the drag coefficient, so that we could build the mathematical model of the AUV that will be used by our software team. As for software matter, we were able to put our AUV onto Gazebo so that we could simulate the codes that were made with the changes of this new AUV. And that closes the wider view of the whole design. But before ending this video, I would like to dedicate it to every and each one of those 46 members of the team for going against all odds and building such an amazing project on a time that during this terrible time the world's going through. And most importantly, for always keeping on their faces a smile and never forgetting to tell that terrible joke that makes an online meeting, even for a second, seems more like a normal one. Besides that, I couldn't end this video without paying my respect to all 500,000 lives that were lost. 500,000 parents, grandparents, sons and daughters. And to those over 2,000 lives that are lost every day in Brazil. With all of that said, thank you so much for your time, and I wish you all a good day.